Okay, let's talk about the latency and the performance metrics. I think this is where it gets really important. On a very high level, the latency metrics are reported in a unit of time. Essentially, it's microseconds. Okay, so you're going to see a crazy big number. And if you're wondering, is it seconds, minutes? It's actually microseconds. IO size is reported in bytes. Okay, and there's a throughput metric, which is reported in bytes per second. And IOPS is just a number, because by definition, it's IO per second. So actually, the unit is carried in the name itself. That's why it's just a number. The performance and the latency metrics are actually accumulated over time, and I'll explain that a bit more. Also, these values like ECT and DL, they're not directly shown on the CLI. Okay, so when you execute the show interface FC1/15 command, we see something. You see these frame input and frame output, right? What are these numbers? These are actually accumulated over time. Okay, that's a very basic concept, but I'm seeing that people don't directly correlate this concept to our analytics metrics. So this number, it's one counter. The frame output is one counter. Similarly, frame input is one counter. Bytes in one counter. Bytes out one counter. We just keep on accumulating the same counter or the metric, and we don't make multiple copies of it as the time passes. Okay, so imagine if it's a 64-bit counter, and every 10 seconds, if I am updating this counter, I keep on adding the additional bits that I received in last 10 seconds to it, and the number keeps on growing, right? So if when somebody asks me that, how long the metrics are stored for interface, I'm not talking about analytics metrics, but if somebody asks you that how long these metrics are stored on the switch, which is a frame output metric for interface FC1/15, what would be your answer? How long do we store this metric? Well, we just accumulate it over time, right? And we clear it out when we execute the clear counters command, but actually it's accumulated, right? That question may or may not be valid here. Making sense? Okay, so essentially it's the same logic that we carry for analytics metrics too. Okay, you'll see that we have similar metrics. We just keep on accumulating our numbers on it. But when somebody asks, how long do you store the metrics on a switch? No, we just accumulate just like interface metrics. Okay, and these metrics are stored as long as we don't clear them out, or the switch is rebooted, or something which clears all the metrics. Okay, that's one point.
But hold on, Paresh. There is a finite amount of space, right, in order to keep those. So we get that question all the time. How long do we keep it? It's not that we keep any more data. It's just some of the data gets redone inside that same amount of memory space, right? So I think we should be clear about that.
Yeah, and we'll cover into more detail of that when we go into NPU architecture. But just remember, I mean, the parallel point here is just think about how our interface metrics calculated, okay? That's one. Number two, think about how DCNM, when DCNM shows you those nice chat and actually tells you that the interface utilization is in megabits per second, how does it calculate it? Okay, I think that's a very basic way the monitoring works. And let me draw some, because I mean, it's just too much to do over slides. So essentially what happens if you're looking at, let's say, our timeline, right? Let's say DCNM is doing polling every 5 minutes. So we have 0 here, then we have 5 minutes here, then we have 10 minutes, 15 minutes, and so on. And let's say at time is equal to 0, we export our bytes in, and let's say we are exporting bytes in, right? And this number is, let's say, 100. Then at time is equal to 5, let's say this number goes to 200, and then 300, and so on. Okay, so DCNM receives this number, or any management application receives this number, right? Not just DCNM. This is how exactly any graph plotting works, right? Uh, so the end receiver doesn't receive the delta, right? Now there are some exceptions to it. There are some products which are capable of exporting the delta, but most of the time it's the accumulated value at that instance. And then what the receiver needs to do is take a delta. So at t is equal to 5, what is going to happen is we are going to take a time difference of the value that we received at 5 minutes, which is 200, and minus 100. And then to find the per second value, we divide by 5, multiply by 60. So this is whatever this number comes out to be, that becomes our bytes per second throughput. And this is the value. Let's say if this number comes out to be X, we plot a graph, and then the number X is plotted on the graph. Similarly, at t is equal to 10, at t is equal to 10, we take 300 minus 200, and then we do the same thing, 5 multiplied by 60. And if this number comes out to be y, we go and plot y here on the. So this is how clear every time interface utilization work. Right, this is very basic. Any questions? Because this is exactly the same logic we are going to carry forward for our analytics metrics. Okay, so on this graph, we have bytes per second on the y-axis. On here, we have time. This is what you see in DCNM. This is what you see in, let's say you're doing polling, manual polling via SNMP, plotting in any application. This is the logic behind it. Okay, so now when we go back to our analytics metrics, these are some of the metrics that are exported via analytics. You see that there's nothing like IOPS, that a raw metric that the NPU calculates. And there's an exception to that, what I'm just saying. So hold on to that exception, because NPU does report IOPS, but it's not a raw metric that the NPU calculates. What NPU calculates is the total read IO count. The first metric that you see here, it's the total count. Remember, it's not a delta since whatever. Okay, and then similarly for total write IO count. And how do we calculate IOPS from it? Actually, we do exactly the same thing, what I just showed you, that we take, let's say, here is an example. Let's say at t is equal to t2, I have the value of 5,000, and then t is at t1, I have the value of 4,900. Then I take a difference of that. That comes out to be 100. And then I have these two big crazy numbers. Oh, by the way, but just by a matter of chance, the difference is 30. And this becomes my IOPS. 100 by 30 becomes my IOPS. Okay, but remember, IOPS is a derived metric. It's not a raw metric that the NPU calculates by looking at the frames. What we talked yesterday, it's just counting the total read IO count and the total write IO count. It's not natively calculating IOPS. Once the NPU has the total count, a secondary level math that it runs looks something like this, what you see here on the screen. Or the same math would run on DCNM SAN insights. Like DCNM SAN insights doesn't receives IOPS from the switch. No, it receives the total read IO count and total total read IO count at every streaming interval, which by default we use as 30 seconds. So this is the numbers it would receive. And then what are those big two crazy numbers that we're using here as a denominator of this so-called equation? These are the timestamp that the NPU uses based on when it's collecting those metrics. Okay, so these are actually Unix timestamp. So if you use this number, and if you do, let's say, Unix timestamp converter. And this is going to be extremely important when somebody is doing detailed troubleshooting, right? When this metric was exported, and somehow if you get hold of this metric, you go here, use any, there are tons of these time converters out there. You see that there's a timestamp that, you can convert. It's the Unix epoch since the start of 1970 when somebody built their first computer, something like that, right? So you see this date, actually it's from yesterday, this UTC time frame. If I go on my switch right now and do a show analytics query, select all from FC's SCSI.port. At the very end, I'm going to see those two metrics, the sampling start time and end time. Don't worry about the start time because there's some more details to it. But if I take this number, copy this, go back to my Unix time converter, put it here, and it shows me the value, which is exactly my time right now. Okay, this is exactly the time right now because this is, it's plus minus, not plus, it's within last 30 seconds range, this timestamp. Okay, so remember.
Can I ask a question here? What I'm not clear is why we do the double calculation. I mean, we calculate IOPS on the MPU, and we do that in any cases independently from the CNM. So the calculation is already done. We put an effort to do that. So why do we repeat the same exact calculation in the CNM? It looks like a waste of time for me. Why don't we get the number out of MPU?
Okay, yeah, very valid question. We'll answer that. Any other thoughts? Any questions? The point that to remember from here is that natively, when we are inspecting the frame headers, we do not calculate IOPS or any performance metric or latency metric directly. These metrics are actually derived from the total counts per se. Like IOPS, we have the total read IO count at T2, maybe 30 seconds before, and then total read IO count now. Then we take a difference, which in this example comes out to be 100, and then we take the time difference of these two timestamps, which are collected by the NPU, and then we calculate IOPS. Okay, so this is not directly derived.
Paresh, quick question. On that, on your average IOPS formula there, you have sample end time and sample start time. Did you mean like sample start time and sample start time? Shouldn't that be the time?
Yeah, I mean, there are some variations of it. Yes, I think that's a good observation, Wade. Yeah, there are some variations to it. Yeah, and I don't want to go in those details because it really depends on. Yeah, I'll show you two variations of it. Now you have raised that point. Let me just show you real quick. So in this query, where FC1/33.
I'm sorry, it should have been sample. I should have said sample end time and sample end time, right? Because you said not to use the sample start time. So you're taking two different queries, one at one end time and another one at another end time. It would be the second end time minus the first end time.
Yeah,
right?
but they were both at T2, so we need to make sure that is fundamentally correct. If you look at that.
Yeah, so there are two variations of that, right? One variation is what you see on the screen. You see the sampling start time is actually a pretty old timestamp. So if I take this value, you see this, right? There's a big difference between these two things. Doesn't look like it's just 30 seconds. And if I take this number, throw it here, it's going to be, let's see where it is. Oh, it's 11th of August. Seems like that's when I enabled it because right today it's 17th of September, right? So this is not going to help me right here. Let me execute the another version of this query. Show analytics query name. No, query all. Query name. Result. Okay, when I execute this, now you see the start time and end time are very close, and actually the difference is 30. You see the 63 and 93 ending in 63 and 93. So there are two versions of it, right? You're seeing the difference? Right now,
So
this
is that based on the view then, Paresh? Is that what you're saying?
no, it's not based on the view. It's based on how we are exporting the metrics. And we'll talk about the timer. So hold on to these thoughts because there are three timers that we're talking here. There's a port sampling interval, there's a streaming interval, and there's a query interval. These value depends on that. Okay. Just to answer your question in short, what happens when we export these metrics, and these are the metrics that you're seeing right now. If you notice what I didn't do a raw query on the NPU. I just did this, show me the result of this query. And by the way, this is what we are sending it to DCNM, right? So what we are sending to DCNM, what we do is when we are continuously exporting these metrics, we copy the timestamp of the previous export end time to this export start time. Making sense, or do you want me to draw it?
Okay. Okay. So that difference should be 30 seconds, right?
Yeah. So you could use both the counters. Now it really depends. There are some minor implementation detail that there may be some minor exceptions that a receiver may choose to do something else, right? Even in DCNM SAN insights, look guys, there may be some bugs here and there. We end up finding some corner case, and maybe next release we change that small minute implementation detail. It's totally possible, right? The points to remember here is this, that you see the start sampling end time and start time. This actually depends on your query interval, which you see this query interval type 30. And this is the timestamp that you must be using. If let's say you're writing a script, I don't believe anybody in this call would be interested in building your own app, even though we'll try to build it in next week. But when you're doing that, make sure when you receive the total counter from here, let's say, where is the total? Let's say you receive the total read IO time and your total write IO time. When you're taking the time difference and dividing it by time, you should always use this difference, because this is what the data collection engine is imprinting with the record, which is NPU. This is your best metric that you can get. Even though there are different places to get a timestamp, this is your best guess, or best bet, not a guess. Okay, there are some details, we'll cover that later, but remember, if you are calculating your IOPS, use the total read IO count, which is here. Take a difference of these two subsequent exports, and then when you want to find the time, hey, what is the time difference between two exports? Use these two numbers. And because we copy the end time of the previous export to the start time of this export, this is where we can have two variations of this formula. Okay, and this should not be considered as the official implementation of SAN Insights, because honestly, yeah, we don't want to talk about that. That's a software design, may change anytime. But a generic concept, that's what it's important to understand, that how if I'm building an app or somebody's writing a script, a customer is building something of their own, this is how they should use it. And this is how we actually calculate IOPS, because NPU is natively not calculating IOPS. Natively, even though it's calculating, there's a difference between what it's calculating as a secondary level metric versus a raw metric that it gets from the frame headers. Okay, so that's IOPS. How about throughput? Exactly the same logic. We don't calculate throughput directly. We have a metric called total read IO bytes and total write IO bytes. We take a time difference, divide by time, and then we get a value. In this example, let's say if at T2, I have the value of 60,000, and at T1, I have a value of 20,000, I take a time difference. That gives me 40,000, divide by 30, because these two crazy numbers that you see here, the difference should be 30, yes. Right, and I get 1.3 megabytes per second. Okay, this is the logic used by SAN Insights. Similar to that, not exactly. Average IO size, again, look, even though yesterday we talked about the IO size is carried in the header, remember our query interval can be more, right? We are exporting every 30 seconds, right? So if there are 1 million frames that pass through the NPU in last 30 seconds, we'll keep on adding the values of all the IO sizes of those frames to a counter called total read IO bytes. Okay, and then we export the same counter every 30 seconds to an external receiver, and that external receiver takes a difference. But this time it divides by the total read IO count to detect that what is the IO size per IO. Okay, so let's say in last 30 seconds, if the total read IO count jumped from 5,000, sorry, from 4,900 to 5,000, and the total read IO bytes counter jumped from 20,000 to 60,000. So we take a difference and divide. That gives me the average read IO size is 400 bytes per IO, and something similar is what you see on SAN Insights. So hopefully you are able to see the transition, the whole journey of a metric, that what we see on a slide, it doesn't work like in a production environment. It's not calculated like that. And when we export, there are clock skews. There's a query interval, there's a streaming interval, and then there's a delay on DCNM too. And we'll do that whole journey probably next week, because we haven't started talking about DCNM. But you see some variations already right now. It's not a per IO count, because there are millions of transactions happening. We can't be reporting IO sizes of all of them. It's just going to kill everything, right? So this is how it works. Okay, ECT, right? Just like the previous counters, we have a counter called total read IO time. What is this total read IO time? It essentially is the sum of all the transactions over the last period. In this case, let's say if it's 30 seconds, what we do over last 30 seconds, we keep on accumulating the value of the completion time in this counter, which is total read IO time. And then we divide by the number of IOs which were completed, right? So if it's 5,000 minus 4,900, so 100 IOs were completed in, let's say, between two subsequent polling or two subsequent export of these metrics, and with the value of the total read IO time incremented from 30,000 to 80,000, it comes out to be 50,000 microseconds. Remember, these numbers are in microseconds. The time metrics are in microseconds. And I divide by 100, that gives me 400 microsecond per IO. This is my ECT. This is what you're going to see on your show commands. This is what you're going to see in SAN Insights, or any receiver per se. If you are building, let's say, if someday some customer end up building of something of their own, this is the math they will be using at the backend. And similarly is the case for DAL.
Hey, Prash, this is a question on the IOPS thing again. So if I have a whole, so I guess it matters where I'm monitoring. Let's suppose I have my analytics ports on the storage ports, and I want to find out how many IOPS a host is doing. What do I need to do? I would need to like sum or aggregate all of the IT's IOPS for all the targets he's zoned with or something? Or is there a way to do that? Or maybe I'm just off base here.
The NPU provides that directly, and we'll go into detail of that later in a few minutes from now. But,
yeah, but does DCNM, like, if I want to find out my host, I want to know how many IOPS my host is doing.
Yeah, DCNM also does that.
Even if I'm not monitoring the host itself?
Yeah, you can enable, let's say, your analytics on storage ports, and it will still report you the IOPS of the host as long as the traffic is passing through it.
Okay.
Right, end-to-end, once in the end-to-end data path. When we actually have a use case of that, it's working in the lab right now, so I can show you in a few minutes.
Okay, great. Thank you.
Before going to a question, there is another concept on SAN Insights, which is a normalized version of the metrics. And here's a concept. We talked about this briefly, that you cannot just compare two ECTs randomly. Like yesterday's example was 400 microsecond of ECT compared to 800 microsecond of ECT. Can you do it? May or may not be, it really depends. But one of the factor here is that you can have an average ECT in which you can say, this is my completion time per IO. But does it make sense to compare an IO of 512 byte, the completion time of a 512 byte IO to a completion time with an IO of 64K? Does it really make sense? And this is where the other concept of normalized ECT comes in play, where we say this is the amount of time taken to transfer a single kilobyte of traffic. Okay, and this is where we come up with a, in this case, we don't divide by the number of IOs, we divide by the number of bytes, right? So this is the formula for normalized ECT. You see that in denominator, we are using bytes. And if you see here, we get a number 120 microseconds per kilobyte. But when we go average, we do 100 to 300 microseconds per IO. And this is, I would say, this is a FAQ. A lot of people look at this in SAN Insights and say, oh, what is that, by the way? This is the explanation for that. And, there is value. I would say I haven't come across any other vendor doing it like the way we are doing it, like the normalized way of doing it. But when we explain it to customers that should you be comparing the ECT of a 512 byte IO and the 64K IO, and the moment we ask that question, people say, okay, this is the right way to do. Right. So there are pros and cons, right? Like this is not conclusive, guys, right? Like I don't want you to go away with that thought that one is the right way and other way is wrong. No, it truly depends on the use case. And the use case is this. Remember, if you are comparing two different hosts, let's say I have server 1 and server 2, the application on server 1 is doing mostly smaller IO sizes. The application on server 2 is mostly doing larger IO sizes. So this is server 1 and this is server 2. And again, server 1 is doing 400 microseconds, server 2 is doing 800 microseconds of response times. And now the second factor is you bring in the IO size factor here. So this is where it gets more complicated and more interesting that, hey, I shouldn't really worry about that 800 microsecond because the IO sizes are larger too. And that's why I need to normalize it. Okay, so this is the explanation of why SAN Insights shows you a normalized versus an average way of average metric. Different use cases, both are valid based on what problem you're chasing. Now, there are some more details to this concept. You can always argue, hey, with all flash, it doesn't really make sense because the moment it finds it, it just sends everything. So actually the DAL is the total amount of time. But after that, all these frames with the larger IO size are sent instantly. So why you're doing it? Because it doesn't really depend on the size of the, IO. There are arguments like that and all of them are valid, right? So when we go with that kind of detail and troubleshooting, and eventually I would say with one large customer, we'll end up hitting those kind of detail. So I would say, remember all these thoughts. And if don't remember, at least remember we talked about them, then come here, watch this recording, and hopefully it helps you in the future. Okay, any questions on average versus normalized version of the metrics? Because you see this in SAN Insights.
One thing just looking at it, I can see we're using different IO block sizes, multiple samples like that, where you get different ECTs for given different block sizes. You can come up with potentially a approximate model for a linear equation to estimate an application's ECTs based upon block size is going to be using within the within that environment.
Yep, absolutely. In fact, let's say if the time permit will go into detail of that, the use case of IO size and predicting your IO congestion. Yeah, I think this has been thought going around within the circle, but I don't think this has been explained in detail. But Tom, what you said is totally correct. Yes. Okay, so how exactly the NPU calculates the IOPS and throughput? It actually takes a total write IO count or total total read IO count and the total write IO count. And this time the NPU is taking an approx 4-second of time interval. Okay, so in some of these slides, and I think even here, I have a slide which says some of the metrics are calculated at 4-second granularity. And most of the metric, like I guess this slide, yes. This also what I've used in Cisco Live. So if you see here, there are 2 bullets here. Most metrics are calculated at microsecond granularity. Some enhanced metrics are every 4 seconds. I hope you have the answer of that question, that why we have 4 seconds and what are those metrics. We have 4 seconds because, guys, understand we are talking at scale. We are talking at like millions of transactions. We are talking of like 40,000 or 20,000 flows in a single NPU. We don't want to be running this math, like these calculations all the time. It's just going to kill our NPU. Our basic aim here is to collect those metrics from the transactions, the live IO transactions that we saw yesterday. We run the second formula, the formula of IOPS every 4 seconds. And I would say that is very, very aggressive. I would be totally fine even if it goes to 10 seconds or 30 seconds. And I'm sure some of the guys from engineering are listening. But this is why, not why, but this is how the NPU reports the metric, which is read IO rate, which is the read IOPS, and write IO rate, which is the write IOPS. Whenever you execute a command, you're going to see something which is the representation of last 4 seconds. This is the real-time view only. You don't get to see on a switch what happened between 8 and 12 seconds from now. No, you don't get to see that on the switch. For a historic view, you go on your DCNM SAN insights.
Hey, Paresh, I'm looking at the metrics in the telemetry guide. It doesn't mention any of that.
Yeah.
All right, I'll file a bug as I'm listening to you.
Yeah, I'm not sure whether we want to document all these things. Like, yeah, that's a separate conversation. But yeah, I mean, right now we're just like, talking like engineers without thinking about. I'll let the sales figure out how to sell this stuff if you guys, find this information useful. But there are always questions that, hey, where is this 4-second thing? And like, what is the granularity of metric? And like, is the every metric at microsecond level? To be very accurate, no, not every metric is at microsecond level. Some of the metrics, like let's say total read IO time, is incremented or is accumulated the moment an IO finishes. Okay, so that's absolute real time as it gets. But if you're looking at a metric called IOPS, no, we have a delay of 4 seconds. Let me show that to you. What I mean by that is, let's say I execute this command, not all, but I just do port read IO rate. You see that number didn't change, and now number changed. The first 2 executions I did back to back within a period of 4 seconds. The next one I probably waited 2 or 3 seconds and then executed, number changed. So this is a real time number. If you execute back to back and you're super fast, don't get worried if the number is not changing. Actually, in the hardware, it's changing. We are not just running that math every microsecond level. We run it 4 seconds. We put it here. After 4 seconds, we do it here again. You'll see these timestamps changing. So here, I mean, no, okay, don't look at these timestamps in this kind of command. Sorry, I take that back. Okay. So, Foster, to a question, that why do we calculate it twice? Why don't we just use the NPU value? Because look, the primary aim, we need to, when somebody is designing, and I'm not the guy, like the guy who wrote the code for it, like, you know, I have deep respect for him and he's not with Cisco anymore. But think about any point of time, if you guys are designing this, what is your primary aim? Your primary aim is to collect those metrics as they pass through, and the secondary level calculations can be done later. You don't want to invest your compute cycles in that, right? And when we are thinking about the end-to-end solution, we want our receiver to do these calculations because that's how it works across the industry, that how it has been working before. Even the switches today, the show interface counters that I used, we have a derived command of that, which is show interface counters brief. You see this, right? Like this is a 5-minute average. This is not, the rate is not calculated by our ASICs. This is what our software is calculating and NXOS is calculating. Like you see this 175 megabytes per second, right? This rate is not reported by the ASIC. The ASIC just reports those two big 64-bit number depending on the register size. So it's the same logic that we have in NPU. But because NPU is using that cycle of 4 seconds, what happens? The number changes every 4 seconds. And if you're exporting this, let's say if you're exporting this every 30 seconds, let's say this is for 8, 12, 16, 20, 24, 28, and 32. And somewhere here is 30. So you export it here at 30 seconds. And let's say at 30 seconds, if you exported or had you exported read IO rate, what would you get? You get the IOPS between 30 and 26th second, right? This is not what you want to report to your user. What you want to report is the average IOPS over last 30 seconds. And that's why we don't export read IO rate. That is only a metric for real-time troubleshooting on the switch. But when we send it to DCNM, or if you're writing your own script, you're building your own app, don't go after this metric. Go after total IO count and the other metric from that formula. Also, that's making sense?
Yes, it makes sense. Even if I have to make a bet, I believe that the difference, the quantitative difference between the numbers would be completely negligible. And so
yes, I agree with that too. And that what you just said is actually the basis of a port sampling mechanism that we have. Right, but yeah, we have to pick our battles, and in this kind of conversation, there's nothing like a right or wrong. It's just like this is better and this is slightly better, so let's do something else, right? It's always trade-offs, right?
Yep.
And when we have to export one metric, one, you know, so and if you let's say if you have to export two, which one would you pick? Both of them can be accurate, so that's the question we need to answer.
Since the divide operation is really a pretty expensive operation at the CPU, when we're doing it, much, 10 times or 8 times faster or more frequently than we should be doing it or need to be doing it, seems like we ought to have a setting in the NPU to do that every 30 seconds instead and just use that metric.
Yeah, I think that's a very valid point. In fact,
I mean, we're concerned about NPU overload and stuff, right? And I know divides are killers.
yeah, back in the days, I guess like 2 years back, engineering did a lot of optimizations, and like this is, yeah, I mean, yeah, I would park that conversation for internal offlines and. Okay, so when you see the read IO rate and write IO rate, remember how we calculate that? That's a 4-second granularity, and 4-second granularity is enough for most of the real-time troubleshooting. We don't digest that fast as an information. And if somebody can, just wait for 2 more seconds, man. Wait for 4 more seconds. It's not going to change the world. You can still solve those problems. Also, remember, if the metric doesn't change within 4 seconds, don't worry. It's by design. And external receiver shouldn't use the metrics because of the reasons that we just talked about. Okay, along with the IOPS and throughput, we also have min, max, and peak metrics, right? And you'll see this in the output of Shukam, like the peak read or write rate, the peak bandwidth. Then we have the mix minimum of IO sizes and minimum of ECTs and DAL. These values are since the last time the metrics were cleared. And metric clearing can be a very different concept. So be aware if you're thinking that, just like we do clear counters with the interface, honestly, I don't recommend doing that for analytics metrics. And there are different reasons for that. Some of the reasons I'll convey. And then this is an open debatable topic. Somebody in engineering can say, no, there's no worry problem with that. Like, without taking names, I was telling somebody, don't do that. The person it did something that shouldn't have happened. But then there are bugs all over the place. You don't want to hit those bugs, right? Also remember, it's such a heavy operation sometimes clearing these counters and things. And that's why we have other mechanisms to get hold of these metrics. So don't clear them out and then try to say, okay, let me see what is my max thing over last 4 seconds now. That's not the best thing to look at. You probably should be using show analytics utility that will talk, or you should be using DC and MSAN insights for those kind of things. Okay, because these metrics like the peak values, min, max values are the values since the last time the counters were cleared, and because at least my recommendation is not to clear those counters, this is probably since the time you enabled analytics on the port or your switch was rebooted. And then we have outstanding IO. Essentially, these are the instantaneous value. Remember, it's an instantaneous value. And guys, this is a very detailed topic. You can go in hours and hours thinking about this, that how do you calculate outstanding IO? There's a whole different algorithms for it. If you talk to Watana guys, I'm not sure if those older guys are still around. There used to be a guy called Nick York. I think with him, I think right next to our office, I ended up talking for hours on this topic. All those details are there. Eventually, some point of time, if some customer hits in that scenario, we'll go in details. But on our NPU, on the Cisco SAN Analytics architecture, every 4 second or every time interval, whatever the time interval is, the NPU sees how many active IOs are there and just reports that number. And this is what your outstanding IO is in a user-friendly way. Here on the NPU, we call it as active IO read count or active IO write count. Day in the life of a metric we'll do next week. Analogy with interface metrics we already did. Please remind me if I don't do this day in the life of a metric. We should be doing this. Okay, so by this time, you guys should be clear. And I'm not clear. At least you should have the explanation of all the counters that we have on the NPU. What is that? What is the granularity? What is mean? Where is my ECT? There's no ECT. Where's my DL? There's no DL. Let me walk you through to SCSI target count. You know that's a metadata metric. That means I can reach one target via this port. This port can be anything, I don't know, but it can be an ISL port, it can be a target connected port, but I can reach one target from this port. I can reach 0 initiators on it. Logical port count, this is my number of vSAN. So I have one vSAN flowing on this port. Target app count, ignore apps. We'll talk about that in a few minutes. Active IO read count. This is the cumulative count, right? Like, so this is actually keeps on incrementing. So, hold on. Is it an accumulated value or is it a instantaneous value? Okay, yeah, I need to recollect my thoughts on that, but yeah, we'll add details on this later. I believe this is a total accumulated value. This is not an instantaneous value, but I need to confirm. There's just like too many details here. IT flow count.
Isn't that the outstanding IOs currently at that time?
Yeah, that's what I got confused for a second. I'm not sure whether this is the instantaneous value at this time or is it the accumulated value since the last time the counters were cleared. That's where I got confused. Not sure on that right now. Okay, then you see about the right, you see total read IO count, right? This is the counter we just talked about. It's a crazy big number, and it's just a number. It keeps on incrementing. Then we have the sequential read IO counts, like, it just represents how many sequential reads we are doing. We don't use this number actively today in DCM SAN insights. Then we have the read IO time. This is used for calculating ECT. Remember, NPU doesn't calculate ECT directly, but this is what we use to calculate ECT by taking the difference and dividing by time difference. The initiation time, this is initiation time, remember, is our DAL. We don't have a DAL sitting in the metrics anywhere. We don't even use the term. You see how consistent we are, right? But here we call it as initiation time. The moment you go on SAN insights, we call it as DAL. Read IO bytes, write IO bytes, the accumulated value of the IOs of all the transactions that have happened, that are hitting this NPU. Okay, time metric based. Okay, this gets interesting. So you see this, there's a total time metric based read IO count, and then there's a total read IO count. Where is the read IO count? Yeah. What is the difference between these two? The difference is, if you remember, we talked about yesterday that how do you calculate your IOPS? Is it the number of IOs which were initiated per second versus the number of IOs which were completed per second? Because what is the difference between initiation and completion? That response frame. Initiation is just a command frame, and completion is that response frame. Okay, and then there are some low-level details. Probably I'm not going to talk right now. It's like very long conversation sometimes, but the time metric based read IO count is the number of IOs which were completed. That means we have successfully received the response of these IOs. This is calculated the moment the NPU sees a command frame. Okay, so it increments the number. There's a command frame coming of a new exchange, it increments this number. But then to calculate the time metric based read IO count, it waits for the response of that exchange to come back, finish, and it's make sure that actually the response, the exchange has finished, and now it increments this number. Okay, SAN Insights actually uses the time metric based numbers. This is, if you have to pick between these two, I would pick the time metric base, but then both of them have a, as you can imagine, different use case. They can solve a different use case. But if you have to pick one, I would say pick the time metric based counters. The difference between what got initiated versus what got completed.
I have a question here. Why are those numbers so vastly different?
I don't know.
I mean, it seems like almost all of our commands would be completed at some point, would be responded to at some point.
Yeah, I don't know, honestly, why it's like that. There could be so many reasons for that, right?
And then my other question is on the peaks. So you said that we keep the peak, it's a single peak for the entire time since cleared. Mm-hmm. It's not a peak within that interval. Is there a timestamp associated with that particular peak? Like, I mean, nope. It wouldn't matter to me if that peak was 6 months old.
Yeah.
But if it happened yesterday, I might want to know it.
No, we don't carry the timestamp, and that's why DCNM SAN Insights doesn't use the peak value or the rate value, because it doesn't know when it happened. It receives that 30-second average and then finds the peak of those 30 seconds from a long period. Making sense?
Yeah.
So what DCNM SAN Insights does is, what happened here? Let's say this is 30 seconds. So DCNM SAN Insights receives every 30 seconds average, right? I'm not making a dot, I'm making a straight line just to convey these are 30-second average values like this, right? And then this is what it may say it's a peak value. This is what you see in the graph. The NPU is actually doing it at every IO level. Out of like 1 million IOs, if one IO, let's say every IO, there are 1 million IOs, and every IO is less than 4K. And then there's a one IO that hits 64K. The NPU will actually show this number to you. Since the time, right? Whenever it happened, you don't know that. But then DCNM may show you a higher number, because if it's hitting 64K, obviously we assume the 30-second average will also go higher. It may not accurately show you 64K. May or may not. It really depends on your kind of incoming numbers and where it lands with the whole averaging thing. But yeah, to answer question in short, no, we don't carry the timestamps. Okay, and then you see the rate. It's 4-second average. Remember the rate, right? The peak write IO rate. This is again as since the time, the beginning of the time. The bandwidth should be clear. The min max values, the completion time min and max. Remember, we only calculate min and max for completion times. We don't carry this for instantaneous value, because that's a very heavy operation for the NPU to do all the time. So we have to pick the battles and report some, like IOPS and throughput, but not report everything. And then you see the long list of error metrics. And at the very end, you see the time metrics. So guys, by this time, I'm not saying you remember right now, but at least you should have an explanation of every freaking counter that NPU collects and how it collects, what is the granularity, why it does the way it does it, things like that. Why we have picked some battles, why we have let go some other battles, because there's always a scale challenge, you know, of like every calculation that you're doing. Remember, just multiply that time takes of the CPU by like 1 million, and then think about whether it's going to work or not.